That's the shortest introduction I've ever had, but okay. Let me just set up my slides. Just as I'm doing, if you ever need to remember when Hume's comic will next come to the solar system, all you have to do is just remember that the series of books 2001 and 2010 has a trilogy, a third movie, which is 2061, where they actually go to visit Hume's comic in the story, and it's actually really, really interesting. And there was something else about when you was mentioning the mold and the things growing on the moon. They've actually known about that since Apollo times. So one of the Apollo missions landed, picked up a camera off a lunar surveyor, and they found inside the camera one of the technicians had sneezed. And so they actually took the bogies, which had viruses in them, and they started growing again in human conditions when they brought it back. Life is tenacious. So yeah, so I just thought I'd share that. You see, this is the problem. I know lots of stuff, really random stuff. And that's why I'm kind of giving this talk. And this is my approach to science fiction, because I know so much stuff about space, not just about microlensing and black holes, which is really interesting because it's the only way we can measure the mass function of single black holes in our galaxy. But you know, the gravitational wave transients. And if you look at my science, which is studying stars across all of cosmic history, I have to know a lot. But then the reason I'm doing that is because of science fiction. And you know, this is not a science fiction image, but you know, how real is science fiction? We have traveled to the moon. If you don't believe that, then just watch the video of Buzz Aldrin decking and hitting the conspiracy theorists when he confronts Buzz Aldrin on the street. Hang on, that should go away. I don't know whether it's not. I click that, it should. Yeah. Okay. So who am I? I'm Professor Dan Eldridge. My pronouns are she, her, them, they. I'm an astrophysicist, so I do physics using stars. I'm the current Faculty of Science Deputy Dean. I didn't actually want to be an academic leader, but it turns out when you're good at stuff, they keep on asking you to do things. I study exploding binary stars while exploding the myth of a gender binary. If you don't know, I'm transgender. What that means is my gender does not align with the sex I was assigned at birth, because I understand myself more after about 48 years than a doctor looking at me after 30 seconds and going, boy, because how wrong can you be? I'll come up to the end of the talk. I'll describe that a little bit. And because you can actually use actually quite a lot in science fiction, even way back to the original Star Trek, we can actually find examples where we can actually not just understand the stars, which I'm going to talk about, but ourselves as well. And I work on lots of things, and you can find me on Instagram, Blue Sky. I still have an account on Shitter, but since it became, it used to be Twitter, but yeah, but I don't use it anymore. And I want to say it's not unusual for astronomers to like science fiction. So I have a colleague, Elizabeth Stanway, who I've known since the first week of undergraduate, which is like a long time ago now. And she went to a conference and wanted to understand how people, astronomers, well, I mean, they are people, but we're unusual, and how they viewed science fiction. So she put up this diagram and had like stickers, so people could put stickers on whether they were influenced or not by science fiction, whether they loathe it or whether they love it, which is interesting, right? Because you're like, how can you be influenced by it? And so this is the blow up of what she found out. And what's actually maybe not so surprising is that lots of people love it. But, you know, some people are not completely influenced, but there is a quite big amount that would clearly influence. And then you actually get this where people are like putting it way off the board, as you can see up here, because they were so keen for it. I can't think of any other field where this would happen, possibly engineering and others. But, you know, I'm not unusual. I didn't get to put my sticker there, so I'm not going to admit where I am, but it's interesting. Maybe, but I don't know if you want me to get through the talk, we don't have to. It's interesting just to see that. And there is actually a sequel paper that someone in France did the same thing. And it's interesting because there are, I think there are subtly different answers from different culture. So I am heavily influenced by Star Wars and Star Trek and Doctor Who, clearly. My career is as close to being Doctor Who as it can be, because I get to explore the universe, show people how interesting it is, and also try to, in quotation marks, make it a better place. If you come to my office, you will find my Lego collection, which is all the Star Wars things I've flown inside the X-Wing series of computer games, because computer games are cool. And I also have a large collection now of Doctor Who novels. I already had some, but Professor Simon Thrush from the Institute of Marine Science was downsizing, and he gave me his entire collection. It's taken me like nearly over a year, but I finally got through to the last few books of Peter Davidson. It's taken time, but I really love sci-fi in all its forms. And I've also met the doctor, so you can actually trust what I'm saying. They came to New Zealand a few years ago. Actually, I think it was the first or second year after I had arrived. And, my doctor was Sylvester McCoy. That's why I grew up. And, you see all the others and they're all great. My favorite doctor is Sylvester McCoy, although I do like the second doctor and, of course, the fourth doctor. I don't think Jen Bailey's on them. So I'm going to break down into three rough bits of science fiction I want to talk about. One of them is going to be about how things move in spaceships. Then I'm going to talk about planets. Then I'll talk about gender. So I just want to remind you how things move. How do spaceships, and that's one of the things we want to have this superconducting magnets in space, because in theory, you can actually have motion in space through magnetic fields by flipping off the Earth magnetic field. It's difficult, but you can do it. But this is how we get into space at the moment. We use the shuttles, which of course we don't use anymore, but this was our state-of-the-art technology. And so we have 5 of these things, and you have to have a big rocket engine pushing backwards to push you upwards, is how rockets work. And of course, this is just Newton's laws, which I go through backwards, because this is what we can think. So, that's the rocket, right? You need to have something going backwards to push you forwards, right? Every action has an equal and opposite reaction. I mean, the space places actually got you really expensive chairs, right, to sit on, because they're pushing up with exactly the same force as you're pushing down on the chair, which is another way of thinking certain laws, but you're not going anywhere. And if that didn't happen, you would shoot up into the ceiling or sink to the floor. Oh, Jan, that's deep. You'll go away and you'll be thinking about that. The other thing is that you've got this relationship between force, mass, and acceleration. So if you have a small mass, it's very easy with the same force to get you a big acceleration. If you're more massive, with the same force, you get a smaller acceleration. Very easy for you to start running, but it's very difficult for you to push a car, okay, just using your own body's energy and forces, which is another way of doing it, which is why you need to have big or small forces as well to get, if you've got something of equal mass, you can vary the force to get different acceleration. And of course, if you don't do anything, you just go in a straight line. We're obviously got a force acting on us all the time, gravity. So that's quite boring. But do any movies actually do this? No. Star Trek breaks this a lot. Star Wars breaks it a lot. And actually, if you look into Star Wars, they have things called etheric rudders. I've looked into it, and it's all rubbish physics. But surprisingly, I would normally talk about Battlestar Galactica here, but I've stopped using it because it's basically a very dark series when you look at the topic of Battlestar Galactica. This is the 2000 one, not the brilliant 1980s episode that we all know and love. Or the 1970s. It came out in 1978, didn't it? Yes, that's the good Battlestar Galactica, but they get physics wrong. Wally, however, gets the physics right. So Wally's dead, or is he? So Eva here is breaking the laws of physics. There's some blue glow, but then Wally's obeying Newton's laws, and he's using a light fire extinguisher. And this is exactly what you would do in space, right? If you had a spacesuit and a fire extinguisher, you'd have fun. But look, they don't suddenly meet up. They've got to not just meet in position, they've got to meet in velocity space too, because they have velocities. They have to match velocities as well as position, which is what you're doing. And you can see the big and then the small little hits as well as bigger hits to accelerate. So this is actually brilliant. When you watch this, it's all wonderful Newton's laws of physics. That's really good and gives you all an excuse to watch Wally over the weekend. But basically every other series is bad. Oh, hang on. I've got the same problem going the wrong way. Because they all ignore Newton's first laws. And actually you can see that if you want to watch an example, the beginning of Revenge of the Sith, where you've got Obi-Wan and Anakin are rescuing the Chancellor off the ship. You see this really long, minutes-long sequence of the 2 Jedi starfighters doing this amazing diving and everything. Like, what are they turning to? There's no air, there's no jets to make them. They're just somehow magically. Oh yeah, they're Jedi magic. Technically, I class Star Wars as sci fantasy, right? Because it's science in there, but it's actually a fantasy story because it's like magic. And you can, though, use Clarke's third law, which is any sufficiently advanced technology is indistinguishable from magic. But as the 7th Doctor said, the reverse is also true. Any sufficiently advanced magic is indistinguishable from technology. Okay. So there is a problem with all of this, though, that's how we know how things move. But how can we actually get places? How can we get to these very deep space areas? And you have to do that, you have to travel faster than light, because all the things that Adam was showing in his show were like all those stars, and that nebula are probably hundreds or thousands of light years away. So it takes light that long to travel. But the problem is, it's necessary in these science fiction shows to open up those very large distances. And the real problem is we don't know how it works. Because in our current understanding of physics, which is basically general relativity, we can't travel faster than the speed of light because you literally can't, because the speed of light is constant. And so if I go faster, no matter how fast I go, I'll always measure the speed of light to be the same, which is where the weird physics comes in. But we can imagine things. And so when we go around all the different science fiction shows, basically there's a couple of different ways we can travel faster than light. One of them is to use time and relative dimensions in space, which is actually to understand space-time and somehow you make holes in it, you bend it and warp it, and so you get round. So TARDIS, there's something called the vortex. I don't know where that is, but it's like extra dimensions which we go through. You can also use stargates and wormholes. And actually, I remember watching the original Stargate movie and thinking, yeah, that's actually a reasonable way you can actually make it work. Although, does anyone know the problem with like most times when they have wormholes and stargates in science fiction? Does anyone know what the problem is? Well, stargates are both ways. Wormholes could be both ways because there's actually a solution of GR, which is Einstein-Rosen-Bridges, which can be, but no, they're flat. Right? They're not spherical exactly. So the wormhole should be a spherical region. The only movie which has got that right is Interstellar, unfortunately. I didn't say it was a good movie. I just said it got the physics right. And actually, that's because, like in Contact, actually the other one that got it right is Contact, right? Because they dropped the thing into this spherical region in the middle, and that's where I've forgotten her name. Well, it's Jodie Foster, but I can't remember the character's name. Goes off across the universe, right? So yeah, Stargates and Wormholes are really good, and it's a great TV series as well. Hyperspace, of course, is the other way where you have, again, it's like a bit like the TARDIS idea, the time and relative dimensions of the space, where you have shortcuts through other dimensions to get to where you want to be in our four-dimensional space. Space and time are all important. Jump gates, again, similar to wormholes. This is in, sorry? Which series do you reckon? Babylon 5, yes, it was in. I've never watched Babylon 5, but I have been told to include this. Star Trek, of course, has its warp drive, which is interesting because what they do, if you ever wondered about warp drive, is here's your spaceship. You shrink the space in front of you, and then you expand the space behind you. And so when you go over that space, so it's as if I took from here to the table, squeezed it down into a centimeter, and then I suddenly stepped. And rather than stepping just to here, because I'd squeezed the space, I'd be able to step over here. Allegedly, but yeah. We can't do this. We have no idea how it works, but it sounds cool, right? But it's imaginative because you can, this is the thing with most of the science fiction, they try and link it back to real physics and our real understanding, which is what we should do. Because many people do say you can't travel faster than the speed of light, and I say that's probably true, but there might be physics we don't know. Quantum teleportation, with quantum leap, I should also include a picture of the new series up here, but I haven't seen it. And of course in Star Trek, which is actually, this is impossible because we don't have the computing power on the planet and probably won't have for centuries to be able to store all the information of the people we are transporting. It's actually a computational problem. You can do quantum teleportation of individual particles, but we're a long way from being able to do that. And of course, the best example I know of is something that's really different, right? Now, if I'm saying our understanding of physics can't go faster than the speed of light, if we want to travel faster than the speed of light, we need to do something completely different, which actually...
We're at Magrathea, I think. I mean, I don't know, we've been twice, and we're still not there, but anyway. You in?
Always.
All right.
I want to get him.
Sorry, what exactly are we doing?
The infinite improbability drive is a wonderful new method of crossing interstellar distances in a few seconds, without all that tedious mucking about in hyperspace. As the improbability drive reaches infinite improbability, it passes through every conceivable point in every conceivable universe almost simultaneously. In other words, you're never sure where you'll end up or even what species you'll be when you get there. It's therefore important to dress accordingly. The infinite...
But the idea is here, it's got to be weird. And actually, if you've ever read the Expanse novels, which I put myself through because I didn't enjoy them, but the story was interesting enough, I forced myself to read them. At the end, the very end, they actually have not an infinite probability drive, but they have a way of traveling faster than light that's more to do with quantum mechanics and is much more similar to this than you might analyze on first example, first thought. So, yeah, I just thought I'd share that. Okay, just to finish off with this, what would a real spacecraft with our current technology look like? It would look like this. So this is an idea that some people came up with, and basically what you do is, this is for an uncrewed mission to another star. So here's your spaceship, and what you do is you drop nuclear weapons out the back, explode them with a shaped charge, and it pushes you forwards. So this is actually an inertial plate on the end, and you're basically surfing on the explosion to push you forwards. This would actually work. People have made little rockets that basically would drop little bombs that explode and push it upward. So it goes pop, 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 pop. But there is a problem that you'd actually have to get pretty far out of the solar system before you do this because of the fallout from the nuclear weapon, because nuclear weapons are bad. But this is the best case you can think of to actually use them. And you can probably get up to about maybe a quarter light speed using it. So that's actually getting to other stars well within human life, within human career, even though it would take several careers to probably build this along. Okay, so we're out in space. What do we see if we go to all the science fiction shows? And of course, we see a nice blue-green world. There's a little bit of green down here in the bottom right. And of course, when you land on the world, you see this, you see nice pine forests, trees, you see a nice lake. You have McCoy here, even actually filling his lungs to tell you how much nice oxygen there is. Yeah, we don't see that, right? Because when we look at all the worlds we see in current exoplanet studies, we now know over 6,000 planets around other stars. They're mostly supergiants. And the worlds we do see that are much more Earth-sized are clearly not like this, right? We're starting to actually do transmission spectroscopy of these other worlds, and we're discovering what gases they're filled of, and they're definitely not filled of any biosignatures. There's no oxygen in there. There is water, there is carbon dioxide, but that's not indicative of life. And if you remember a few months ago, there was that K218b, where everyone got really excited to say, there's biosignatures. There's not. If you actually read the paper, the people are overstretching quite a lot. And while those people believe that they found the biosignature, everyone else is kind of disagreeing. And actually, the way to actually know that that's the case is NASA didn't get involved in the press votes, right? If it was really true and without a question, they would have been involved in it, but they weren't. So this is not a realistic picture. But in the early 60s and 70s, when we had these TV series, they had to use the local park. And so for their filming locations, because, you know, you can make, or you can just go to your nearest quarry pit, like you do in Doctor Who, with Blake Seven. So yeah, there's a reason for this. But, you know, we may find planets like this in the future. They wouldn't be like this. We would have to terraform them to have Earth-like life. Everyone knows in Star Trek why you have the Klingons, why you have all humanoid species of life, right? Do people not know that? Would people like me to tell you? So basically, thousands of years ago, maybe even probably millions of years ago, there was a species evolved and they were alone. They were the only intelligent life forms in the Star Trek galaxy. I need to say that, otherwise you're all going to think it's our galaxy. And what they actually did is they then seeded a bunch of stars and worlds in a helix pattern. And so within the Star Trek universe, portion of the galaxy actually has all these worlds of human with the same DNA as these initial founders who have now died out. And that's where all the species come from, the Cardassians, the Klingons, everyone, they're all the same. And actually the last season of Star Trek Discovery also extended that story. There was something in The Next Generation about it, where they were actually discovering this, but they actually went back to find the last gift of those founders to all life. And they destroyed it because it would have been too amazing a thing for us to have. So again, there is an explanation in Star Trek universe, because we know this is probably not true now. No, they destroyed it. Oh, let's not go there. Okay. So, but in Star Trek and other series, though, they do have nasty worlds. And this is actually a world we know kind of happens. It's like a terrestrial-sized world with a nasty atmosphere that if you put some humanoid outside without a spacesuit, they will die much quicker than they do in this episode. But you will still die because you couldn't live there. There's no oxygen or anything else, or live there without being in the space station. And of course, Doctor Who, they even have New Earth, right? Because they went through the entire galaxy, found a world with a sun that was just like our Earth, a planet just like our Earth in the same distance from the sun, and they terraformed it. And so they then went to New York. No, so good they named it 3 times. So that's really good. Again, this is a running theme in all science fiction. But even in Doctor Who, you can actually go and look at it and you can find out that they do have weird planets. And so you're wondering, why have I picked these 2 planets? Can anyone name what these 2 planets are? We got any really dedicated Doctor Who fans to know what the one on the left or the right is? Terek Nor on the left, I think, and on the right it's Voga. So on the left, this is from the new series, and so it's a planet orbiting a black hole. Yes. Audience participation is hard. Okay. Okay, well, this may be Toknor or something. It's something like that. It's not exactly that. It's like, I think you're right. I'd have to actually go and check. So this was actually from a chapter I wrote in a book about, or a chapter I wrote for a book about Doctor Who in science. So I've actually written about science fiction. That's the freakiest thing. I'm now an expert, I think. This is true. This could probably be true, where you have a planet around a black hole. Because the first planets we did find in the galaxy were actually orbiting another type of dead star called a neutron star. Now, they've got to be very weird type of planets because they were probably formed from the detritus or the rubbish left over from the supernova. If you were to get, though, maybe a black hole, I was thinking about what would be special about this planet. Well, you could have 2 neutron stars in a binary neutron star, and they can merge with gravitational waves. We know this, we've seen it. They release a lot of stuff, and the actual stuff they release, because it's come straight off the neutron star, goes for the heavy elements, which are gold, platinum, silver, and all the other precious metals, which is interesting. So from this black hole, if it came from a binary neutron star merger, and you know the physics works out, it would have formed a planet. So this is actually true, but this planet is actually really, really old. It's got plating or big enough. But then in Doctor Who, we've got this planet on the right, which none of you can remember, which is Boga, which is the planet of gold, right? Which would have been formed from binary neutron star merger, because that's what comes out of a binary neutron star merger. Like, it's about a Jupiter's mass worth of gold. We know that most of the gold and platinum and silver in the universe come from binary neutron star mergers. And Voga was a gold planet, so in the Cybermen wars, it was really useful. Cybermen have a weakness to gold, and so they have the glitter gun, and that's why they have gold guns. But it's the remnant of Voga. Sorry, I get excited. I speak too quickly and too much. I need to remember to slow down. It's like, so you can get weird patterns. And what's weird is you're all thinking like, how did you put all this together? And it sort of fits together when you think about what we're actually finding when I was writing this chapter. And yes, in science fiction, we may have these really strange worlds, and some of them may not, they're not completely outside of theory and what could possibly happen. Of course, you're not going to have life on a planet that's only got gold, because chemistry is a lot more complicated. And actually, let's not go into gold chemistry. I haven't got time or the knowledge. But for this chapter, I actually went through every Doctor Who episode, because, you know, what else you got to do? You've got to have some data. And what's interesting is I wanted to actually know that in the old series, which ended in about 1986 or 7, I'd have to remember the exact date, we didn't know about planets around any other stars. But in the new series, which came out in the early 2000s, we knew about planets around other stars. We knew about hundreds of them. And so surely, because we knew that there were planets around other stars, the new series would visit other planets more often. Makes sense. Yeah? No? Maybe? I don't know. So this band down the side, out of all the episodes in the classic series and all the episodes in the new series, these other things are other worlds. And also, though, with Doctor Who, it's weird because they go to dream spaces, nowhere, and other universes. But then this is Earth. So the original classic series spent about 57, 58% of its time on the Earth. The new series is about 65%. That's actually a jump. But so even though there was a change in us knowing more about the universe, they stayed on Earth more often, which is because they wanted people to watch the show. Because if you went off to fantastic places, people would lose contact with the show, which is why probably in season, well, when the Doctor regenerated into the third Doctor, they stayed on Earth so much because they were worried about the show's rating. And of course, towards the end of the show, you can see that they actually went on to other planets more often than Earth. Okay. Yeah. This is research. I got to go through all the Doctor Who's and read the transcript. It was great. And actually, it was interesting because I got one of them wrong. And one of the editors of the book said to me, like, "But Jan, in that specific episode, the thing is revealed to be Earth, even though it's called something else." And I was shocked. Anyway, just lastly on planets, there's something coming up about, so Anne did mention the moon being habitable. One thing that people are looking for is exomoons. So this is moons going around other planets. And I got about another 10 minutes. Okay, another half an hour? No, okay. Okay, 10 minutes. Okay, I could do 10 minutes. And of course, here is one of the best images we have of moons. Why? It's important because there's your volcanic eruption on Io, and you can see that it will glow with the lava. But most of the planets we know from our exoplanet surveys are giant planets. We don't know yet if they have moons going around them. But considering how many moons, for example, go around Saturn, as you saw from Adam's image earlier on with the stellarium, there's got to be moons. And when we look at the moons of the solar system, okay, they're not Earth-sized, but they are moon-sized. The moon is actually pretty big, so it's not completely unbelievable to think that you could have moons of some of these giant worlds that would be Earth-sized, or could be. If there aren't any Earth-sized moons of giant planets in the galaxy, that tells you something about how planets form and moons actually. And of course, Titan is the one exception here that actually has an atmosphere. There's a hydrocarbon atmosphere, so it's not like oxygen, because all the oxygen would escape. The molecules in the atmosphere are very heavy, so they can't. Well, it's also very cold, which is why they can't escape. And we see these moons in science fiction, right? So actually, if we're trying to think about finding life around other worlds, around other stars, then maybe we need to actually start looking at the moons if there are so many gas giants. And this is one of the reasons people want to find the exomoons. And of course, the examples are, what's this one? It's called Yavin 4. Really? Sorry. I did once have a quiz which was name the odd one out, and it had all these different moons, and I can't remember what it was, but everyone used to go for the science fiction one, but in fact it was one of the other ones. Like, say which one of these has an atmosphere? No, can't be that one. Yeah. Anyway, so that's Yavin 4. Sorry, it's like I'm getting really deep in here. But actually, Star Wars has it again, because everyone said Endor. You never see the gas giant, right? But they call it the forest moon of Endor. Where's the gas giant? It's not there. So yeah, so I just include this. But of course, you've all seen the Ewoks cartoon TV series, yes? So I'm being joking here, you haven't. But you actually see the gas giant in the Ewoks TV series. So it is there if you watch the cartoon, which I think is on Disney Plus. So yeah, I'm helping Disney with their advertising. But of course, the best example of all of this is actually with Pandora. And actually what's normally, if you've watched Avatar, you've probably all completely tuned out. It's a moon around the gas giant. Prometheus. Yeah, it's called something funny. I don't know because I can't remember the name. I just know it. Polyphemus. Okay, thank you. And there are other moons, and so this is where the future story might be going. But it is something that's like, it's shown, but you don't tune into it, which is actually really interesting, I think. So anyway, so we see lots of things in space. We see lots of things in science fiction. We can explain some of the things we see in science fiction with our current understanding of science. Not everything, but it's actually interesting to make this link. But also these moons are where we're actually must be trying to find things. It's the next step of trying to understand how planetary systems form in our galaxy. A quick aside before gender is, can we terraform worlds? Because if we find all these moons and they're this hazardous, can we do it? And so this is from Firefly at the beginning. You actually find out, our Earth was dead, so we went to a different solar system. And there's many different planets. And some of the richer ones are all fully terraformed, but the poorer ones are. So actually, that's an interesting story. But the idea is you just have a machine that's solar powered and changes the atmosphere. If you wanted to try doing this yourself, you can play a game and terraform Mars. There's a game called UFO Arclight. Don't do this if you've got exams or anything coming up. And it's part of a series. One of my favorite computer game series of all times is the XCOM series. And so I played it since the first one back on the 1990s, which was really bad, through to these ones, which are UFO after Mars, after light, and after shock. So after Mars is the Earth has been invaded, everything's collapsed, and you're leading the fight back, which is cool. But then the other one is set many years later, when humans have lost, basically, and the aliens did what they want to do. And one is set on Earth, trying to reclaim it, and the other one is set on Mars. And part of the game is to try and understand what's going on, but also it's to terraform Mars to make it look like this, which is actually quite spectacular. And what's weird is it's actually correct. So the northern lands of Mars are shallower than the southern hills, and so you would have this lake on the north of Mars, which is quite cool. It's also really annoying because you lose all your mines in the area, which is your resources. But it's a great story because there's what's going on, and of course there's a combat bit. But great, okay. Hang on, I just want to say one more thing about that. But of course, Mars doesn't have a magnetic field, which is a problem because we have a magnetic field here, so you'd be exposed to all the solar wind. So there is you have to build these things, I think, which give you a protective magnetic field. One of my colleagues in America came up with a paper where if you take Olympus Mons, which is the biggest volcano in the solar system, you mine it for superconducting material, and you put a superconducting wire around the equator, you can give Mars a magnetic field. So this is actually true. And the final point I want to say is actually in all of this is one really interesting thing, especially say with Mars, if we find even microbial life there, should we go there? And another thing science fiction can do in quite good detail, and this is a really bad episode, it looks terrible, but the ideas behind it are great. It's called The Colony in Space. And so you've got this planet where some colonists have turned up. They want to live there, right? They've taken all their investment, moved to another planet to make it a going concern. But there's indigenous life, right? Yeah, and it's green, because that's what aliens are, right? And so, so how do they factor into this? But then the mining company turn up because they want all the minerals from this planet to go back and sell on Earth. This could actually happen, right, in our own solar system. How would you balance these three things? And of course, the indigenous life is complicated. The master turns up. I shouldn't tell you that if you've never seen it. The mining company try and do all these nasty things, but they come out worse, and I think they'll get killed in the end or something. But the colonists win, and the Doctor and Joe Grant are all happy, and they cause problems, because they normally do. But yeah, so that's another way of looking at science fiction. It's a thought experiment to examine things. So we can also think about what science fiction, books, TVs, film. Actually, this is actually a question, mate. I should have thought of this and actually read my slides for tonight. I've given these different talks, not all together at the same time, but I've given elements of them over time. And this is an important one. It's a really good way of talking about gender diversity. Because, what science fiction books, TV, film, do you know that gender diversity, that we talked about gender in an interesting way? And what sometimes surprises people is that Star Trek's been doing this for quite some time. So if you remember, there's a couple of episodes. I could go on for hours just using Star Trek. I've only got a few examples because we're running close to the time. Although I'm sure Anne won't stop me if I go on for another 5 minutes. Everyone else walks out. And so they come across in this episode the outcast, an androgynous species called the Genii, who have evolved beyond male-female identity. And Riker and Soren have a relationship because a few percent of the Genii still have gender, or still feel like they have gender. And then Soren is discovered, undergoes psychokinetic therapy or conversion therapy, if we call it today. And what's interesting about this is, and why I sometimes talk about this, is a really interesting idea that you can have a society without gender, and they're against people having a gender, which if you have a gender, which I'm assuming most people do, you would feel in that society very out of place. right? It will be very scary, which is kind of sometimes what it can be like to be non-binary or transgender today, because you don't feel like you're in with everyone else who is normal. So yeah, it's a very good reflection in science fiction, but it's just a reflection of our own society sometimes. And what's interesting is Jonathan Frakes thinks that Soren should have been played by a man, not a woman. But then this is the 1990s, right? The 1980s. And it's like that was all known in Star Trek. But yeah, Jonathan Frakes is a very interesting character. But there's an even earlier episode in Star Trek called Turnabout Intruder, where Janice Lester steals Captain Kirk's body. I don't know why you'd want that body specifically, but anyway. And in some ways it's terrible because there's lots of casual misogyny in it, right? So you have this mind swap, which is by some ancient magical thing, because I won't go into it, but the technology to do this is impossible, right? Because you are a bunch of neuron links within your brain. So what this machine is actually doing is reconnecting everything in the different brains within a few seconds. And it's like there's too many atoms to do it. So it's almost, anyway, so it happens. And Janice Lester goes around going like, oh, wow, I've got so much energy. I'm bouncing around. Like you would just think that, you've got the normal amount of energy. And the Kirk in Janice Lester's body goes, oh, I'm so weak because I'm a woman. It's like, what? Because you've got normal hormone levels in these two people, right? So you'd actually be normal. But anyway, there would be differences because, if you start to transition medically and you change your hormone profile, you basically, so you've all heard of first puberty, right? But what about second puberty, right? So it can be quite hideous. And that kind of, I don't know if that would happen here because the brains are adapted and there's lots of things when I think about this and try and get into the science. But yeah, anyway, the good news is Kirk gets his body back. But I will say Sandra Smith here, who plays Kirk, is one of the best actors that ever played Kirk because she just plays him so well. But it's interesting, but it's actually, when you think about it, quite horrific because she still forces him to give it up. And that's actually quite nice. But there's things we can learn from it about him. A couple of final ones is Jadzia Dax is perhaps the most interesting exploration of gender that's been on the show. Because she's a trill, and trills have little slugs that live inside them called symbiotes. And when the host dies, that slug or symbiote gets passed on to another person, and then another person. And so I think by the time it comes to Dax, she's had about 6 previous hosts. What's her gender? She's lived as a man and a woman. Now the host is a symbiote is in another female body. But it's interesting watching her, especially when she interacts with the Klingons. And many people see her still as Curzon Dax, the previous host. Because Benjamin Sisko always refers to her as old man. What you see. But the important thing here is that Klingons actually get trans rights. Right, so Kor is an old friend. He was in the original series as well of Curzon Dax. And they're meeting for the first time. And so Kor is like, oh, what do we do? Because he changed. And Dax goes, just how about giving me a great big hug? And Kor, the Klingon, goes, Curzon, my beloved old friend. And this is what Klingons do, right? Because Jadzia goes, I'm Jadzia now. Like, corrects the name and pronouns, probably. And Kor goes, well, Jadzia, my beloved old friend. The Klingons get trans rights. Correct the names, it's fine. Honorable. What's really special for me, if you haven't been watching Discovery, do go and watch it because it's an amazing series, even though it's much maligned. And actually, one of the reasons I like it is I've seen myself in Star Trek for the first time. Right? I actually cried when we came because it's amazing because you actually have you have the like the 80s or 90s TV series My Two Dads. This is My Two Gay Dads in space. And so they adopt Ensign Tull and Gray, who actually goes back to Trill because she's the Trill, but through the symbiote, it's not symbiote, she's a synthetic. Anyway, it's complicated. Watch it, it's great science fiction. But yeah, she's transgender and Tull is non-binary. So I'm seeing myself, and it's only one set of characters. There's lots of other cis characters still around, so it's great. Oh, Jet Reno's here because she's the queer auntie. Because you actually see the two dads get worried because Tal is going off on a away mission, and so Jet Reno comes along and just does her auntie kind of activity. Tig Notaro, who's the actress, is actually quite fun. So just to end up, there's also lots of books about this, and if you've never read any Ursula Le Guin, whenever you talk about your favorite science fiction authors, especially if you're my age or older, you always think about, Asimov, Clarke. My favorite book is The Songs of Distant Earth by Artsy Clark, which is interesting. But Ursula Le Guin was co-temporal with these people, and yet she's not really widely known. But Left Hand of Darkness is an amazing story because it's actually about an ambisexual culture where every human can be either sex when it comes to reproduction, because it's a really harsh environment. So, you know, if you actually just meet someone else, you need to have children for your species to abide by, so you would make that change. Maybe that's what they've done in Left Hand of Darkness. And the ending makes me cry. But yeah. Ancillary justice is great because everyone uses she, her pronoun. And if you read the story, you're trying to figure out what's the sex of this person because they're all using the same pronouns. And in the end, it doesn't really matter, but it's an interesting story. And with the Raven stratagem in Yoon-Ha Lee, there's trans and non-binary characters all over, but that's because Yoon-Ha Lee is a trans man himself. And it doesn't add anything, so it doesn't take away anything from the story. It doesn't necessarily add anything, but it's just reflecting normal human diversity, which I think is key. And just to finish up, of course, you know, you've had a Doctor change gender, which is interesting because this is the same thing, right? You've had how many Doctor Who's? 12? And then she changed. And actually, this I really like, where if you do transition, it's interesting because it's like right now I'm a stranger to myself. And there's echoes of who I was, and there's a sort of call towards who I am. And I have to hold my nerve and trust all these new instincts, not instincts, and shape myself towards them. I'll be fine in the end. Anyway. Do you want to know more? Or would you like to know more? Where's that a quote from? Yes, which is Starship Troopers. Okay. So anyway, if you want to know more, my colleague Elizabeth Stanway has this really amazing blog called Cosmic Stories blog. So you can just search for it, Cosmic Stories, University of Warwick. She considers everything in science fiction. I know about science fiction. She's several orders of magnitude more knowledgeable than I am. And look, she's talked about plant people, astronavigation, super submarines, because she's watched it all. And it's actually interesting. I've done one guest post, I'm going to do another one. So yeah, this is a really interesting blog to read, and it's got a lot of stuff to read. If you ever want to think about a specific bit of science fiction, I can guarantee it's there. You can also find on Radio New Zealand the Sci-Fi Sci-Fact podcast, which is actually, there's like so many podcasts, it's got to be nearly about 60 different podcasts of different scientists, including me doing a few, talking about things. I talked about neutron stars, exoplanets, Turnabout Intruder, about gender, but also Santa Claus. So I talked about the physics of Santa Claus and how, you know, I mean, you all know that Santa Claus uses quantum physics to get around and deliver all the presents because he makes into the quantum multiverse. Okay, yeah, good. So yeah, these are two really interesting resources if you want to think about this a bit more. And some of the things they do on sci-fi, fiction are really interesting. Otherwise, remember science fiction is science fiction. The stories first and foremost, and sometimes science is created to tell that story. And sometimes these cool ideas inspire people, which is really good. And I'll finish with some quotes, which is really good, even though we're quite nowhere near lunchtime. But yeah, I'll leave it at that. But thank you very much for listening. I hope that was interesting, and I'll answer any questions anyone has.